In this video, we will be going over graphing dilations, finding scale factor, and finding the center of dilations. So we're going to build off of what you guys were doing in the investigation, some things you were figuring out that occurred with dilations, and we're going to go from there. So I just have a dilation, on the cover page here. We have our pre-image, which is ABC, and then our image, which is A prime, B prime, C prime. And you can see that each of them, you kind of think of it like shining a light and having the shadow be the dilation. We could get a shadow that's smaller than us or larger than us. So kind of think of it as coming from the same point, and that center point is going to be like our light source. Okay, so first thing, just going to go through each of these. Remember, you should be using your handout that you got in class. And so first thing is just being able to read the notation. So if you look at the notation, it looks similar to other transformation notations we've used, where we've had one letter that is the letter that's the first letter of the name of the transformation. So since it's a dilation, we have the letter D. And then after it, in subscript, in the little print, will be the important details that we need to do the transformation. So in a dilation, we need to know what the center is. So if you look back at the previous page, the center is where the dilation is coming from, or think of it as that light source. So first we need to know what the center is, and second we need to know what's the factor that we're dilating by, and that will tell us whether our shape should be getting larger or should be getting smaller. In this case, our center is O, which just like in our other transformations, O means origin, which is 0, 0, and our scale factor is 3. So think about whether you think this shape will be getting enlarged or it will be getting reduced. So you guys figured this out from the investigation on dilations, where we actually just gave you points and then you examined them. You saw that whatever this scale factor was, it actually was taken and multiplied by all of the ordered pairs to get the new ordered pairs. So if we write a rule for it, thinking of our coordinate rules from transformations unit, that rule would be 3x, 3y. So I'm literally taking the scale factor, which is 3, I'm multiplying it by the x value of every point, and I'm multiplying 3 by the y value of every point, and then I'll get my image point. So when I come up with my answers here, all I'm doing is plugging them into that formula. So the first point would be negative 3, negative 6. If I take negative 1 times 3, I get negative 3, and that negative 1 is coming from my D. And then I multiply negative 1 times 3 and also negative 2 times 3, and that's how I got the negative 6. So I'm going to do that to each point here, just taking the point, plugging it into the formula. If we're starting with E, 2 times 3 would be 6, and then negative 2 times 3 would be negative 6. So that's 6, negative 6. F, again, plugging it in, I would get 6, 9. 2 times 3 is 6, and 3 times 3 is 9. And then finally for G prime, negative 6, negative 9. So I've already gone and graphed the original pre-image shape in red, and now I'm going to graph the image in blue. So all I've done is I calculated the points, then I plotted them, I made sure that I labeled them correctly, and then we connect them, and we see that we have the same type of shape. The angles are the same here. All we've done is enlarged it by a scale factor, so it's proportional. All of our angles are the same, but our side lengths have that factor of 3 relationship. So make sure if you need to that you pause the video to get all of that down. The next example you guys are going to do on your own. So if we break down the notation here, we see that it says O again. So our center is the origin. We're going to find our new points the same way we did in the previous example, except for this time our scale factor is now 1/4. Now if you observed that when we had a scale factor of 3, which is greater than 1, our shape got bigger, and if we have a scale factor that's less than 1, you may be able to predict what would happen to the shape this time. Remember, there's there's really two options for dilating. So I want you guys to do this part on your own, but I've given you, sorry about that, I've given you the rule on your own already. So let's erase kind of what I had there. I don't want to get ahead of myself. So this is the rule. All I've done is taken 1/4 and just converted it to decimal, so we're still taking the scale factor and multiplying it by all of the x values and all of the y values to get our new image points. So I want you to take w, x, y, and z, plug it into this ordered coordinate rule, and then get your new points and plot them. Plot both shapes. And if you want to, as you're doing it, highlight the new shape so it kind of stands out to you, so you know which one you started with, ended with. It's really important to also have those prime apostrophes on our labeled points, so when we look back at our notes, we know, how we got these answers. So pause the video and complete that one on your own. Okay, and then finally an example when the center of dilation is not at the origin. So if we break down our notation, we notice we don't have O listed first anymore. We have -1, 4. So that's going to be our center, and we're not going to be able to just multiply our ordered pairs by the scale factor. We're going to need an actual grid. So, in the last ones, we could have done the dilation without even plotting it on the graph. But for this one, you actually need to plot it on the graph. So we're going to start off by graphing our shape, ABC. I know it's kind of small, but just graphing 0, 4 for A, 1, 3 for B, and 1, 5 for C. Okay, so the next thing we're going to do is we're going to graph our center. So my center is that purple point on there. I know that it's all kind of a little close together, but bear with me. If you look at the center, -1, 4, to get my new points, I'm going to basically be using slope, which is in turn, kind of like the distance formula. I'm going to be using distance from the center to the pre-image point, and I want that distance to be multiplied by 4. So that's something you guys also figured out in your investigation. You found like O to A. We were calling O the center. So you found O to A and then O to A prime, and you saw that all of those distances were also multiplied by the scale factor. So we're going to go from the scale factor. We're going to find out the distance from the, we're going to go from the center, find the distance from the center to one of the points, and then we're going to multiply that distance by 4, which is the scale factor. And because I'm just replicating the distance, I'm going to be using it in a slope way. So if I look at A, the slope from the center to A is, we have a rise of 0, so I put 0 on top. I want to look at rise and run. And I have a run of 1. So, and I kind of put that in purple on the graph, just showing like that movement of 1, that one spot away that it is. So I'm going to take that slope and multiply it by the scale factor, which is 4. And I get 0 times 4, which is 0, and then 1 times 4, which is 4. So now I'm going to go back to the center, and I'm going to put A prime, a slope of 0, 0, 4 away from the center. So if I go from A to A prime, from the center to A prime, I'm going to go up 0, so I'm not going to go up at all, and I'm going to go over 4. And that's how I find my A prime point. So if you're a little confused, just wait. I'm going to go through 2 more points. But again, I've taken the slope to get from the center, which is the purple point, to each point, and then I'm going to multiply that slope by the scale factor. So again, if I do it for C now, the slope from the center, which is my purple point, to C, I rise 1 and I run 2. So I've taken that 1 over 2 slope right here, and I'm multiplying it by 4. So I get 4 over 8. So now I go back to the center, and I go up 4 over 8, and that will give me my C prime. So I've just gone back to the purple point, which is the center, go up 4 over 8, and I get my C prime. And then finally I'm going to do it for B. if I count the slope from the center, the purple point, to B, I have a slope of -1, 2, and I want to pay attention to the fact that I need to be going down when I replicate it. So -1 over 2 multiplied by 4 is -4 over 8. So I go from the center, the purple point, I go down 4, and I go over 8, and I land on B prime. And as you can see, it looks like the same shape. It's actually positioned the same way. We're just going off of a different center. It's kind of like our, we have to shift a little bit in our graph, but so make sure you are counting from the center. And if you have questions about this right now, jot them down. We'll talk about them in class. Okay, so on to now finding the center and the scale factor. So I already have this down in my graph. I've drawn 3 lines, and basically, and you guys did this in the investigation, the lines are being drawn between the corresponding points. So corresponding points would be like L and L prime, K and K prime, J and J prime. So wherever the point started and the point where it ended, those are corresponding. So you want to make sure that you use a ruler when you do this, because you may, miss your point if you don't have straight lines. But I've drawn lines between, and they all intersect at the point. I think I put that as 0, 0, but you know what? That's actually 0, 1. So let's fix that. Oops. So we see that point is 0, 1. That's our center, and I'm just looking where all of those lines intersect. And then to find the scale factor, we're going to use this formula down here, which is image length over pre-image length. So I need to find the length of one of the sides, the image side, remember, which is afterwards, and I need to find the length of one of the pre-image sides, and I'm going to put them together in a ratio. So I'm using distance formula for this part. I found the distance of K prime L prime, which is the image length, and because I had a run of 1 and a rise of 2, I went and plugged those into my formula using the shortcut that we've been talking about recently. And I find that K prime L prime is square root of 5. I'm going to do the same thing for KL. So I look at the rise and run of KL. I have a run of 2, a rise of 4. So I plug that into my distance formula. 2 squared plus 4 squared. And I get square root of 20. Now, just like in the investigation, we want to simplify our radicals so we can really see what the scale factor is. So I've broken that apart to square root of 4 times square root of 5, because 4 times 5 gets me 20. And 4 is a perfect square, which is the goal, to get out a perfect square. So I take the square root of 4, which is 2. So the answer for KL would be 2 square root of 5. Now, I have the lengths now. I need to put them together in a ratio, making sure that I put the image length on the top. So I put 5 over 2 square root of 5, and then I'm just going to work on simplifying that, and because I have a square root of 5 both in the top and bottom, I can cancel those out, and I'm left with 1 over 2. So just like we figured out in the last part of the notes, that if something's enlarging, the scale factor will be greater than 2. If it's shrinking, it's going to be less than 2. So greater than 1 and less than 1, and that's what we have here. Our shape has gotten smaller, so we have a fraction scale factor. So almost done here. We're finding the center now of our last example, so make sure you use a ruler, connect those points that go together, and we see that all the lines intersect at -1, 5. And then to find my scale factor, this is actually a more convenient case. If I look at side KJ and K prime J prime, those are actually vertical, so I do not need the distance formula for this. I can just count it. If there's ever a horizontal or vertical side, I want to use that one. So K prime J prime is 6 and KJ is 2. Make sure you put the image on top when you put the ratio. and I get 6 over 2, which is 3. And then just to verify, my shape should be getting larger, and I can see that the shape with the primes is the one that's getting larger. So that's it for our notes. Please make sure if you had any questions, write them down and ask them in class, and I will see you in class.